All right, we are going to continue our discussion on ratios. We're not quite to similarity yet, so take a minute if you can, do this warm-up. You can just stop the video, see if you get it. What I'm asking is if the measure of the angles have this extended ratio 2 to 3 to 7, then the triangle is what kind of triangle? I'm asking if it's acute, if it's equilateral, if it's obtuse, and maybe it's scalene. Try to come up with a description for the triangle based on what the angles measure. So you can stop the video and do that. We'll go over that tomorrow. Okay. The next thing that you need to know are some additional properties of ratios. These are important because I don't think you've seen them before. So the first property there, number 3, says if A over B is equal to C over D, then A over C is equal to B over D. So basically, they're flipping some things around. They're flipping the they're flipping the B and the C. Okay, and number 4, the property there, if A over B is equal to C over D, then A plus B over B is equal to C plus D over D. So all that's saying is if you add the same number or variable that is in the denominator to the numerator on both sides, then they are still equal. So it's kind of interesting. All right. Let's keep going here. This is also additional vocabulary. We're going to talk more about what this means in a few examples. It's called the geometric mean. Now, typically when you hear the word mean, you think of the arithmetic mean. And you use the arithmetic mean to figure out what maybe your average was on 2 tests. So this is something a little different. It's called the geometric mean. You don't really use it all that much, but it has to do with ratios, so that's why we talk about it. So it says the geometric mean of 2 positive numbers A and B is a positive number x, such that if you cross multiply, x squared is equal to a times b, and x is equal to the square root of a times b. That'll make sense in a few examples. Let's look at this. All right, so tell whether the statement is true. I've got 2 examples here. Both examples, I start off and I say, if this, then this must be true. So I'm analyzing whether or not the second part is true. I don't know if it's true or not. Based on my properties, I need to decide. So my first one, part A, says S over 10 is equal to 15 over T. So basically what I want you to do is I want you to look at your properties on that same sheet and decide if it applies to either 3 or 4. And if it does, then you are safe, that property then makes the statement true. So for part A, do they switch these two? It doesn't look like that's what they do. If you look over here, it looks like they switch the S and the T and maybe something else. So that property is not being seen in this. But does the second property show itself? So I'm looking, is this evident in part A? Am I adding some factor to the numerators of both sides of my equation that's the same in the denominator? No. So actually, this statement is false. Let's look at part B. So you have here 3 over x is equal to 5 over x. Looks like they're adding something to the numerator. So your instinct is to decide if it's property 4. Okay. Looks like they're adding x to the numerator on the left-hand side, and they're adding y to the numerator on the right-hand side, which is exactly the property. If you notice the property here, if you've got b in your denominator for this section and d in your denominator for this section, you add b to the top and then you add d to the top. So this is actually true. let's talk about sequences for just a second. This is going to help you understand what the geometric mean is. So an arithmetic sequence is a sequence where you add the same thing each time. So if you are looking at the first sequence here and you're wondering what you must add to 2 to get to 5, you add 3. To get from 5 to 8, you also add 3, and so forth each time. So you can predict what the next few terms will be. From 14, if you add 3, you'll be at 17, add 3, 20, add 3, 23. And you could keep going. The common difference, and you'll study this next year, is actually 3. It's whatever you're adding to each term to get to the next. And a geometric sequence, which relates to the geometric mean, you're not adding something to get to the next term, you're multiplying by some ratio or some number. So to get from 2 to 6, I'm thinking I'm going to multiply by 3. To get from 6 to 18, same thing, multiply by 3. And there is my ratio, my common ratio, or my common factor. If I were to keep doing that, you could calculate this as 486, 1,458, 4,374. All right, so the common factor is whatever it is you're multiplying by each term to get to the next. So in this case, it's also 3. All right, so let's look at an application, kind of an application of the geometric mean. So the geometric mean is always found using 2 numbers. You're asking yourself, what's the geometric mean between 2 numbers? So in this geometric sequence, 4, 20, 100, each time it looks like you're multiplying by 5 to get to the next term. Now, 20 is the geometric mean of 4 and between 4 and 100. So the way you figure this out and the way it's related to ratios is this. If you looked at these 3 numbers, 4, 20, and 100, and you found the ratio between the first 2, you looked at 4 over 20. And if you simplified that, you would know that that's 1/5. That ratio between the 4 and the 20 is just 1/5. And then if you looked at the ratio between 20 and 100, you would also see that this ratio simplifies to 1/5. Okay? So the geometric mean between 2 numbers creates this common ratio between the numbers. So for example 2 here, if you want to find the geometric mean of 3 and 300, basically you're looking for some number in between 3 and 300 so that you can create this common ratio like I did up here. The way you calculate this is just like I had earlier. You can look back if you want. The geometric mean is just the square root of a times b. In this case, it's 3 and 300. So x is equal to the square root of 3 times 300, which means x is equal to radical 900, which means x is equal to 30. All right, so if you were to check and see, you would see that there's a common ratio between these 2 terms and these 2 terms. Okay? All right, let's see if you can find one on your own. There we go. All right, so find the geometric mean between 35 and 175. You can stop the video. I'm just going to go through it. So x is equal to 35 times 175, which means x is equal to the square root of 6,125. Try your best to simplify this. I can see right away that 25 is a common factor, so this is radical 25 times, and if you have your calculator, you can do this, radical 245. All right, so I know this is just going to become 5, but let's see if I can simplify this anymore. So radical 245 is radical 49 times radical 5, and this becomes 7. All right, so if you think of this like your factor tree that you've done a while ago, maybe that'll help. So your geometric mean is actually 35 radical 5. It's kind of weird. But if you were to put that number in between those two, 35 and 175, and you were to figure out the ratio would be common. All right, last example. This one's pretty easy. Back to proportions in maybe a more familiar way. So here they tell you that PS divided by, so here's PS divided by SR is equal to the ratio of PT divided by TQ. All right, so the formula, or the ratio that you can set up is just what they give you. PS divided by SR is equal to PT divided by TQ, and you can just start filling in what you know. So you know PS is 5. You don't know what SR is. PT, they tell you, is 8, and TQ is 10. So you can find SR simply by just cross multiplying. And you can just do that real quick. 50 is equal to 8 times SR. SR is equal to 50 over 8. And if you simplified, SR is equal to 6.25. All right, so we'll do some more examples with the geometric mean and some more challenging ones in class.